question would probably ask you to find the measure of each angle. So what would we have to do with x? If I ask you to find the measure of each angle, what would we have to do with x? For that 18, yeah.
Times 18 by 3.
Right. Yep, we'd have to plug it back in to each one to find the actual degree of each angle. Let's see. We'll look at the second one and we'll skip the third one. If we look at the second one, the one in the red, and they told us to find the value of x, how would we go about doing that? They give us this exterior angle and two opposite angles. How would we go about doing that? I don't remember the number. I think it was 5.3, maybe 5.3, where they said that this exterior angle. Go ahead, Anastasia.
Maybe find out the other angle by doing 2x plus 18 equals 24.
Right here.
Yeah.
Not quite. You are correct that we have to take that 2x plus 18 and add 24, but we need to set it equal to something. Any idea?
It equals the opposite.
Can't set it equal to 180 because that would be the whole triangle. We don't know what's going on with this side yet. I think our theorem 5.3 said that we can take this exterior angle and it is equal to the two opposite angles added together. So 2x plus 18 plus 24. So then we could solve for x and have it written down. I don't need to go through the algebra right now. But x would equal 114. So just to review what we did last. Learning targets. Students will be able to use side angle side congruence theorem. So side angle side, SAS, will become very familiar with that. Students will be able to solve real life problems using side angle side. No surprise there. Can you see what I'm writing on the board there? Why don't you just grab a chair and sit there so you can see what I'm writing. What did we do that? Did I put that slide on there twice? What?
Yep.
That's all right. So, writing a proof. Have we ever done anything like writing a proof before? I mean, I know we haven't in geometry class, but have you in any of your other classes done anything that you would say is close to writing a proof or giving a reason for the steps that you take? Rough draft. You're talking about with like English class?
Yeah.
Oh, like you give a thesis, right? And you have to give your supporting arguments?
Yeah.
Yeah, it's a little bit like that. That's a really good comparison. I should have thought of that.
Mistake jar.
What?
Mistake jar. Put a coin in it.
I don't know if that's a mistake. But, so if we are writing a proof, now we have this algebra problem to start out here because we're pretty familiar with algebra. We've all taken algebra. I think that this would be a good starting point to show this algebra, and then we'll get into stuff with triangles. So when we are writing a proof, the first thing that we want to do, and you'll definitely want to make sure, hey, you can't see the board. Sit down. You sure? You can see what I'm writing down?
Yeah. I don't know how you can see behind me in English class when you do that.
Hey, that has nothing to do with math class right now. Make sure you can see what I'm writing down, because you're going to be, can you see what I drew down here? Exactly. Sit in the chair, please. I did draw something, so you can see it.
You drew a little scribble. That was it.
Sit in the chair, please. I'll make sure that you can see. if we were to write a reason for every step we take, if this problem said solve for W, we first, whenever we are writing proofs, you can't really see that red. Whenever we're writing proofs, we want to start with just stating what they've given us. Okay? So if we were going to start out with this one, we would just start. Why can't I write? We would start by just stating what they've given us. So this is our statement. On this left side, you'll see a statement, and then we need to give a reason. On the left side of the statements, we're listing our steps. On the right side, we're going to give the actual reason for why we can do them. So when we look at our geometry proofs, a lot of times that the reason will be because of one of the theorems we've talked about. All right? So if we were to solve this problem for W, what would we want our first step to be? What would it have to be, actually? Yeah, Anastasia? Right, we'd have to distribute that -5. So we would get negative 35W minus 40 equals 30. So when we're giving the reason for these things, our first reason would be, so this was given, right? We just rewrote the given problem. Our reason for the second one would be because of the distributive property. What would our next step be for solving for W? Someone besides Anastasia. What would our next step be for solving for W? Yeah, add 40 to each side. So W is negative 35W equals 70. Now, we haven't talked about this, and you probably don't remember seeing this name from algebra, but technically the reason that we can do that is because there's something called the additive property of equality. So if we're giving a reason, it would be the additive property of equality. It just says that if we add something to each side, then it's still equal. So additive property of equality. And you don't need to know the additive property of equality. You don't need to know this algebra stuff, but I'm just using the more familiar stuff from algebra to give us an example before we look at the geometry. What would be our next step to solve for W? Someone besides Anastasia and Laman. What would be our next step? Sawyer, what do you think? Next step?
I don't know.
Negative 35W equals 70. We're trying to solve for W.
Simplify?
Kind of. So we would want to divide by negative 35 so that we can get W all by itself. So if we divide each side by negative 35, that would give us W equals 2. And the reason we can divide negative 35 by each side is because of the division property of equality. So again, I'm not worried about you guys understanding each and every step here, because this is just supposed to be a little bit of a review and an example from algebra. The thing that I want you to... What? What was that? Negative 2?
Yeah, it's -2.
There's one for the mistake. The thing that I want you to see is we give the statements, which is just how we solve, and then how we are listing reasons. And again, our reasons a lot of times will be theorems. So here's the theorem that we'll be working with for today. And this is one you definitely want to have down. Theorem 5.5. It's our side angle side congruence theorem. All that says is that if we have two triangles, and these two triangles have a side, and then an angle, and then a side, in that order, that are congruent, then the whole triangle has to be congruent. So that's what we're dealing with today. Emma, send me a chair, please. Yes, ma'am.
Yeah, but that's the same.
Also, this is not up for argument. Please sit in the chair.
But you're not drawing anything. All you did was retrace the lines that are already there.
So this is the main theorem that we're working with today. So make sure that you have this down in your notes. You also want your notes handy because we'll be looking at a lot of the theorems that we've talked about previously, even in other chapters. So you'll want to have those ready to look at. You have that down, Layla. I can see maybe you're still reading.
Well, no, I
You're
have it
good.
on mine.
You're good?
Yeah.
I'm still writing.
Oh, sorry.
Girl, you have it on your iPad.
She just has
Girl,
it
I
now.
don't care.
She just has a blank screen on it right now. I can wait.
The slides are on campus.
Do I look like I care, Layla?
Obviously you did.
It's all good. We got time. Kind of. We have a pretty big assignment today. But we'll have at least 30 minutes to work on it. So. Good?
Mm-hmm.
All right. So now let's look at a proof if we are using side and side to prove that these two triangles are congruent. So first we start with the given. Like we said, we wanted to start out stating what they have given us. So first they let us know that BC up here is parallel to DA at the bottom. And then they are congruent, my fault, it's congruent. They also tell us that BC is parallel to AD, so they tell us both things. They're congruent and they're parallel, kind of makes sense. We want to prove that these two triangles are the same. Alright, so we want to keep in mind that we want to keep in mind that theorem that we just looked at. Side, angle, side, because that is how we're going to prove that these two things are congruent, by proving that they have two sides, or a pair of sides that are congruent, that they have one angle that is congruent, and then a side that is congruent. So if we look at what they have given us already, they've already shown us that we have a side that is congruent. They told us that BC is congruent to DA. So we already have one side down, so we're good. Now we need to prove that they have an angle that is congruent. How do we think that we would go about showing, or what angle do you think would be easiest to show that it is congruent? Which I know is being pretty vague. I just want to see if we're watching and have any ideas. What do you think? Which angle? So you're talking about this angle, this angle. We're looking to show that an angle is congruent. We know BC, you're right. We know that BC and DA, that those lines are congruent. Those sides are congruent. So that's where we're starting off. But now we need to see if we can prove that an angle, two angles are congruent. Let's try this. If you were looking at this transversal, remember all the way back to chapter 3, when we looked at transversals and we looked at corresponding angles, alternate interior, alternate exterior, all that kind of stuff? Do you remember? Marissa, can you take that one off for me, please? Chapter 3, we looked at alternate exterior, alternate interior, corresponding. Is any of this ringing a bell? At all? Okay. We're looking at our two squares. Right, we have two. Whoop. We have two parallel lines like they told us, and then we have a line that cuts through them. So we can kind of think about it like we're looking at a transversal that we've looked at in the past. Now, if we're trying to prove that angles are congruent, then we talked about alternate interior angles, so angle 2 and angle 3. And remember we said alternate interior angles are congruent. Okay, so going back to what we talked about a couple chapters ago, that would tell us here, angle C, or BCA, and angle BAC. Are congruent. C, A, B. We can see that these two angles are congruent because they are alternate interior angles.
It's just a bunch of scribbles. I don't even know what that says.
Well, I just said that out loud. Alternate interior angles. Because they're alternate interior angles. Now we have proven that a side, we have proven that a side, we have proven that an angle are congruent. Now we need to prove that one more side right in a row. What side is a pretty obvious one that they have in common, that have to be the same? Which one? BA and CD. So those will be congruent because they have congruent triangles, but we can't prove that at this point. What side do they share? What side do they share? What side is in both triangles? Yes, Anastasia. AC is in both triangles. So we just proved that our side is congruent. We proved they gave us one side. We proved that they had an angle that were the same because of alternate interior angles. And then we just proved that stated that the other side, the side that they share, is congruent. And the reason for this would be because of those properties we looked at last week. This would be the reflexive property that we looked at last week. The reflexive property said that I think it used triangles, but it said that any triangle ABC is congruent to itself. It's congruent to the same triangle, ABC. Same thing applies for length. Skip that example. I would like you guys to look at this practice problem. So in this practice problem, it asks you to write a proof. Your proof, just like in the ones that we looked at, you should have your statement, and then the reason. That statement is just going through. First, you need to show that they have a side that is congruent, and then an angle, and then a side. So use those theorems that we talked about earlier that you've written down. And I think then we can get to a proof here pretty quickly. And I'll let you know the assignments.